Holochain. So.
Are you recording, by the way?
I am recording.
Great.
Hopefully, I don't run out of space. All right. Yes, I'm going to say Holochain. So, this is something I discovered about a year ago. I'm not actually part of this technically, but I've been very interested in sort of volunteering on all the stuff that they do. So, first part, really want to explain it's not freaking blockchain. So it's got to sound like blockchain, but it's not blockchain, and it's really important that we understand that. So this is a non-blockchain architecture for distributed or social applications, right? So having people involved in the applications, right? So my name is Marcus. I'm still an undergrad at UTS. I study applied physics and complexity. A sort of a dual degree. So I'm interested in lots of very technical things that are very abstract. So yeah, discovered Holochain a year ago, and a year ago I started learning to program because I didn't really know how to do much. I knew a bit of MATLAB and a bit of data visualization stuff, but this was like I wanted to learn how to be a web developer because I wanted to be able to build these Holochain apps. So it was really cool. Part of my sort of academic background is I'm really interested in collective intelligence. So I'm really interested in how people make sense of the world together, and sort of how academia and disciplines and stuff play a part in that. So so I'm really interested in how we can improve that, because I think there's lots of some people that may have been involved in sort of PhDs or whatever here. There's sort of some interesting problems in the scholarly academia space. So I'm trying to address some of that. So I'm just going to reiterate, please interrupt at any time. Like I know we've got 10 minutes of question time at the end, but it's like I want you guys to follow along. So if anyone's got any questions, feel free to stop. Right, where's Holochain? So I can be really quick to me and Nathan will talk about how it's really cool and go really out there, but I'm just going to try and pull this presentation back and explain what actually is it, pretty simply. So firstly, it's called blockchain. So Holochain, who's a web developer here? You do web development? Cool. So if you're like, you could use Holochain in many ways, but one way you can do it is for building web apps, right? And Holochain would replace your backend in your web app.
Your database or
your database and middlewares, I guess. So you can interface directly with it because it creates the APIs and everything for you, right? And I'll understand how you'll understand how this works. But mainly, this is important because for a fully distributed app, you can actually have it running on the user's computer themselves. So the person using the website, or like using the web app, they run it locally. And you can make that really easy to do. So, the actual applications themselves, which is like the database, it's private and fully peer-to-peer, right? And so Holochain actually enables you to create fully peer-to-peer databases. But it can be a bit scary at first. You go, well, like if anyone can contribute to this database and add whatever they want, how does that work? So this is where something like blockchain has tried to address this in having consensus mechanisms and stuff. This takes a different approach. So how the data is actually stored in these databases, it's a bit like BitTorrent. So it uses distributed hash tables. So this is based on content addressable storage. So the idea is that if you have a bit of data, who knows about hashing? So you can hash that and you spit out a string, and this uses a string about 46 digits. So you always, like for any unique piece of data, you would get a completely different hash for it. So this enables you to actually create a key value database. So if your key is your hash, and then the value is the entry itself. So the value actually generates the key for itself. Cool. And we'll get into this, but you can actually create graph databases on top of this. There's another layer on top of this, which is becoming quite popular now. But most importantly, these distributed hash tables are validating. So you can't just add any data to one of these distributed hash tables. There's a rule set that all of the peers of they as to like what they can do. So if they're, I think I've got a red thing here. That's not gonna work. So for creating, updating, and deleting entries, but everything's transparent, so you can always read, which is interesting. And then well, this gets to the graph database structure, but you can link and unlink entries in the data. So I'm sure you guys have seen this. So this is sort of what we're talking about in blockchain. It's like we're trying to move this way. So the current world in many ways is centralized. So we have cloud-based services in the middle. So everyone's trying to connect to that. So it's becoming more centralized. But we want to be able to create a more robust and resilient internet in many ways. So that's about taking us to a world where every person is a node that can be connected to many other nodes, and you can actually build mesh networks and stuff off this. You don't have to rely on ISPs and stuff to do your networking. So this gets into what actually is a distributed hash table in relation to the relationship to a network. So this is like the real network of where, like, you can think of this sort of like as the globe of where nodes are situated. So we have, so a node is like someone's computer or even a mobile or something, and they're connected to other nodes. But then, so that they can share data between each other. But you can abstract what data is actually being shared in what we call a distributed hash table. So each of these nodes here is actually like a data entry. So you could have one node here, for example, that stores on their computer these two entries. Because we've got the 2 lines.
So would that entry be a database for hash? Or
Yes.
just one entry into a database?
Yeah, so we'll get into sort of examples,
Okay.
but yeah, so the idea is like if you're like this would be the database, but to distribute the database rather than like to effectively shard it out, you actually have each node store a little bit of it. So this node is responsible for like maybe not like these two nodes, these two data entries in particular, but like maybe this section of the network. So like everyone takes a pie chart of the network.
So no one stores the entire database on their own system.
Yeah.
So but you do have it shared, like the same data shared on multiple systems for.
Yeah, so there's redundancy. So this is a simplified model, but you could have like this node also stores something with other nodes. So you could have like like a level of redundancy. So maybe like you need to have 5 copies of the same thing. So that this creates resilience. So if someone drops off the network, it's always there. So I just like, is everyone following with like what a distributed hash table is? So it's a hash table because it's a table, like a key value pair. So like a table, but it's got 2 columns. So it's got the keys and the values. So that's what makes it a hash table. But what we can do on top of that is we can start building graphs. So instead of just having the because if you join that network and then you just uploaded something, you have an entry floating in this virtual space that no one knows like what it is, what's in it, or whatever. But if you actually start linking things together, you could have like a restaurant. So a restaurant says that it's located in a city. So you could have people could query a city. So maybe we have Sydney as an entry. So it's like, what's a location? Sydney. And then we go, what links off that? And that's something you can query in this database. So get me all the restaurants in Sydney. And so you could actually query that. This is getting a bit deep into like how you actually use these Holochain applicators, but it becomes quite useful to actually to create links between things so that so it actually becomes a functional space that people can utilize. And this is more a complicated system, so you have multiple people. So this is like you have like a very complicated email system. This is what it would look like. But I'll come back to that.
So I'm guessing because each entry has to have its own unique hash,
Yeah.
the entry cannot change. It must be immutable.
Yeah, it's
right?
immutable. Yeah.
Yeah.
So all entries are immutable.
So to change it, you go create a new entry which overrides it somehow. Or...
Yeah, so you can update.
Yeah.
So update is essentially like you basically add metadata, which is like this, like it's like a strike through. It's saying ignore this,
Yeah.
but it's still there.
Yeah.
People can still access it. But you say it points to a new entry. So that's actually one useful way of using these links. Is and this happens automatically when you're building these applications. But you can say if you're doing an update to an entry, it's like maybe someone accidentally wrote Sydney with a lowercase s.
Yeah.
And so if we want uppercase s, it's like we update that location actually. So that if someone goes to that entry with using that hash, it goes to Sydney, but then it'll take them to the latest version of that entry.
Yeah. So similar to blockchain, we'll build up in size over time and without missing.
Yes, it's all monotonically increasing, so it's like you're always adding more.
Yeah.
There's no garbage collector.
Yeah.
Yeah. Which is like if you've heard, has anyone heard of IPFS, the Interplanetary File System? So that's basically like it's a system like this, but it's not validating. So the idea is that anyone can upload any entry, and they can shard it out. But like they have a garbage collection system, so people have to like deliberately pin an entry for it to stay there. So it's always going to be there. But like, so if I uploaded like a video and then my computer is the one that's going to be serving that video if anyone tries to access that entry via the hash, that would be served from my computer mainly because I'm the core source of that. But it's still sharded out within this network, a bit like sort of BitTorrent. Like someone's the initial seed of the BitTorrent of the torrent file, but then there are other nodes that have bits of it, and then they will help serve the file. But Holochain is different because it is all immutable, which is where you can start making comparisons between blockchain.
Sorry, question. So this has to be part of Holochain, like Holochain not be a graph like network.
It doesn't have to be. Yeah. So it's like I could say to Nathan, "Hey, I've got a hash value. Like maybe it's like a video, and I'm like, you can see my video if you query this hash." So then he goes to his computer and goes get video, given the hash, and then he'll get the video. But like that's not easy to do. Like you want a way for people to be able to very easily like be able to operate without actually having to talk outside of the network, which would be quite useful. But you'll see that agents themselves. We talk about agents as like a peer in the network, a person. They have their own address, so you can actually query a person and then what links off them, which would be quite useful. So if you author like a comment or a post, like you can actually query all of their comments and all of their posts, given that you know their address. So
that's probably worth saying too. There's no one single Holochain.
yes.
Maybe explain that.
So that's right. So all of these connected nodes would be for one kind of application, right? They don't have to be necessarily like within all of the applications. So it's like just me and Nathan want to have our own Twitter, just us two, and and then it's just us, our two nodes in the whole network. And then when we create this distributed hash table together, and no one else has to be a part of that. So and this is where you can actually get scalability, where you're actually like people don't have to be involved in something they don't want to be involved. Like maybe there's an app where people are sharing lots of videos, and it's like I don't want to have to store big
but
video.
when I for example scroll down the feed, then I want to request a video from you, then it shares between us two. But there's no reason to share it with everyone else because that would be really
yeah, so it's kind of different. So if we were in one application and you uploaded a video, it would be sharded out between all of the nodes in the network.
Yep, okay.
Right? But what we could do is also create a second Holochain application which enables us to have that interaction where we just share that video between ourselves and we just form a distributed hash table between ourselves. And so that could be kind of cool.
Okay.
you can also have distributed hash tables where it's just one person, which can be really interesting. And we can get into like private health data. So like someone could have their own private data and they only want to reveal it to certain people. So this is like an interesting alternative to the government's plan for health data. All right. So sort of going back a step. So we want to sort of get more the philosophy of like what we're actually trying to achieve here, because Holochain comes from a different place than Holochain. So then blockchain. So sort of like blockchain comes out of a very capitalistic process, sort of the economic theory that's prevailing at the moment. Holochain comes out of what's called the meta currency project. So there's people who have been trying to rethink money and rethink currency and try to make us sort of invert our brains about how we think about this, because it can be quite interesting when you do so. So Holochain is built to serve this end that they're trying to achieve. So one way to define currency, which they've gone back to like what is a currency, the original definition back in the 1650s is a condition of flowing. So it's about accounting for flows in a system, right? So it's like a flow of value. When we think about money as like a flow of value between like you and me. But a currency doesn't just have to be for monetary or labor-based transactions and value flows. It can be for a whole number of things. So so it's an accounting tool. We can use it to understand living systems, so complex living systems. So currencies enable us to sort of visualize the space between interacting agents, like what's going on between them. So the flows and the signals between them, the relationships, and it's all the internal dynamics of the system. So we can actually think about a whole lot of human behavior has the human organism, sort of as a whole, a social organism has internal dynamics that guide its behavior, and all of those dynamics are a currency. So so currencies enable us to see the flows in a social system. Right? So we're when we're accounting for business interactions, we can actually say, so money went from there to there. What does that mean? So if money means labour, transactional service costs of product sort of flow, you can infer that. But you can actually see that like when we're talking about just money as your only measure of doing that, it's like, well, was that a product exchange, was service exchange, labour? Like what was the actual real value flow that was going through that? So we use money as like this one thing to account for all of that, and when you're trying to just use one thing to account for all of that, it gets really hard to infer what's actually going on under the surface. So what we're really thinking about with currencies is like, could you have if you think about it at the very extreme end, could you have a currency that helps us account for everything? So a different kind of currency for each thing we're trying to account for.
In blockchain, they have something called double entry, like the journal recording. I'm not sure whether it will be the same as in technology.
So double entry accounting is like one. It is definitely one thing that you can use for a Holochain application. So one of the applications I really don't want to get into, but it's called Holo, and confusingly, it's not Holochain, but it basically has what they call a mutual credit currency, which is where it's like a system of owing. So if everyone in the room was all part of this Holo application, we would all start with a balance of 0, and then maybe like I give Nathan a beer, and then Nathan owes me like 5 Holo credits. So what happens is, for that to happen, Nathan goes down 5 credits, so he's in debit, and I go up 5 credits. But the sum of all accounts is still 0. So that's an interesting use case. But what's happened there is you've had double entry accounting. So his book, in his ledger, individual ledger, he's gone in the negative. In my book, I've gone up. And we can countersign our transactions to achieve that. I don't want to get into that because it's too complicated. Do you have a question?
does it mean that wealth is just a lot of people owing you things? Or does it frame the system so everyone just aims to get back to zero, so you can't build inequality?
Yeah, so it begins being agnostic about that situation, but then you can add other things on top of that that can affect the behaviour. So primarily, it's for accounting for who owes each other what, but then what do? You can slap on interest if you want to do that. So maybe there's an interest system. So like if you owe other people, but like that's problematic. But you could just have a reputation system on that. So if someone if someone typically goes back to zero, then it returns back to zero, then you can sort of give them a high reputation and say they're paying it off when they've gone into debt. So the idea is that people could have a credit limit, so there's only so much you can go into debt, and but your reputation could actually increase that credit limit. So you go more into debt when you really need it. Anyway, I won't get into that, but we can talk about it all later.
But so unlike blockchain, you wouldn't have to back up any transaction with previous transactions, basically.
You do. So every action that you perform, because we like to talk about actions, not transactions, but every action that you perform is that you have to log it to your, we'll talk about later, but your private chain. So everyone has their own personal blockchain in Holochain. So it's like, and that personal blockchain can be used in multiple apps separately. So if we, let's see, it's a bit complicated. So like this node may also participate in another DHT at like sort of adjacent, so there's another app, but then they still contain what they call a private ledger. And so that would have your list of transactions that you've had with other people, which would have the signatures of the people that you have interacted with as well as your own signature. And that's all part of like, because it's a blockchain, it's like a Merkle tree. So everything's cryptographically secure. So you can't tamper with it and then have it change because everyone would know. So yeah, you basically can't lie about your transaction history and say, oh, I can go into debt now, but you go no, because everyone knows what your how into debt you are, because you can resolve the history of transactions. And this is all part of like when you're actually writing Holochain applications, you write this stuff in. Like, do I need to audit that person's private chain before I can transact with them? Yeah, so it's a rule that we need. Cool. So, but I want to talk about more generally, what is a currency in this system? These are currencies. So we say Alice knows Bob, right? Knowing in this world is a currency, right? It doesn't have to be like Alice transacts $100 with Bob. It's like Alice knows Bob, and that's like useful information. So that's it. You can account for that for other means, right? So the fact that Alice knows Bob could be useful in many ways, right? Or and knows Bob since some time ago, right? Or the fact that Alice and Bob are both part of the same group, right? So they're a member of a chess group.
So there can be like hierarchies of like labels, like nose could be then broken into like acquaintance or friend or
Or whatever you want to do. Yeah. You just add you just find sort of the kinds of relationships that you want to slot them into if you want to do that, or you can just keep that free and open for them to sort of define whatever their kind of relationship is, sort of free text field. But it would be nice to be able to categorize it and come up with like levels of closeness. So again, I just want to this is a really interesting slide because it's like this is what currencies are when we talk about them. So it's not just like tokens. It's not things you can gamble with and trade necessarily. It's just like this label is useful information and because it's representing a flow. So Alice knowing Bob is a kind of interrelationship.
To me, it seems like intuitively it doesn't feel like a currency because I can't trade that bit of information for a bit of bread.
Could maybe.
Yeah, so
As in,
it's accounting
How you
for
use
flows.
Okay.
and
It's
what they want
accounting
to
for
use.
flows.
Yeah. Right.
So it's helping us to understand the space between agents. Right?
Okay.
Like, I mean, I guess Facebook is, that's what they're doing. Like, they're
Yeah,
trading.
well, they actually use graph databases.
Yeah, what they do, yeah, but
Yeah, all the nodes are the agents.
but yeah, they're trading our information for hard currency, hard money.
Yes. But do you see that information as a currency?
I mean, not
It's
in too
No.
many sections. Yeah.
It takes a bit of inversion because it's going back to the old definition of what a currency
Yeah.
really is. But
Right.
we've just got caught up in like the currency is money, and it's just like we really want people not thinking that way. That currency can be not money,
Okay.
right?
So then, what's the value of this if it's not, if this isn't being used to be converted into like actual, hard currency like money? Why is it of value?
So
Is there a future point where this will be the currency, and like what future point would that be? Like what would it look like?
that's the currency.
The money.
You could replace money with accounting.
Yeah, this is where we're kind of getting to is like we use money to account for things.
Yeah.
Right? But what if you could not have money and still account for things so that people can like coordinate?
I love the idea, but what if I have a chicken and you have a chair, and we decide that my 3 chickens is worth 1 chair, and we swap them? It seems like money is a great intermediary to be able to swap many different things.
Sure. Yeah.
So you
Are we
could just
replacing that
give
name?
someone 3 chickens and they on this thing. You put that transaction in to show that you owe this person 3 chickens worth of whatever.
I mean,
Of chair.
we're not saying don't use money.
Okay.
You can use that for those things. But there's like a whole bunch of other things that you can account for that don't involve money.
Okay.
Right.
So
Like the reputation layer you were talking about to infer how much someone can go into debt. Maybe it's based on how many of those nose labels that they have.
Yeah, well, you could have like, I don't know, this is getting into China stuff, but you could have reputation. It's like, are they a reputable like person to deal with? And like that's an interesting thing to put on top of. Like, it's not just like, do they have a lot of money and can they afford to like buy the thing I'm selling them? It's like, well, like I don't know, like are they a good member of society? Which can be like, this is very China, but we don't want to go too deep.
This is not
That's
centralized.
bad. That's a bad.
are they a member of the chess group? Do they?
Yeah, like are they in a trusted group? Like, yeah, you can say like, is this person someone who's trying to do good in the world, like fix climate problems and stuff? They're not like making things worse. And then like maybe that's someone you'd rather transact with, But like it's not like a rule that you can't transact with that person. That can just be information for your personal accounting. So when you're choosing who you want to interact with, you get to choose. But you can base it on real evidence. Right?
So it'd be good for identifying maybe super connectors, people who have good social currency, but at the moment you can't. It's hard to
Well, at the
quantify.
moment, Facebook has all of
Yeah.
that, right?
Yeah.
Yeah. Like Facebook could like show the degrees of separation between people and stuff all through this
What
stuff.
happens if people they don't use Facebook at all?
Well, they're still on there.
Shadow profile.
Yeah.
Yeah, they're fake. So okay, so this is where we're going to get a bit more deep. So yeah, what we're trying to enable is like a level of social coordination which is better than what we have currently. So money allows us to coordinate, but like you can have even more sophisticated and consistent organisms. So this is actually a key concept we use in the construction of these Holochain applications. We have this thing called the DNA. So a social organism is essentially all of the people involved in running a Holochain application together. But there's a DNA which defines it constrains the relationships you can have with each other. So if we're saying like, if Alice is relating to Bob in some way, like we're saying there could be maybe a list of kinds of categories that they can define their relationship in. So it's like the label is knows, or like maybe you can have is friends with, or hates. And then like maybe those are the 3 rules as to like what kind of relationship you're allowed to have. But that's not a very useful one. I'll go to an example as soon as if I can. So let's say you like maybe me and Nathan want to play. You know what this is? Connect 4. Okay. So what we can do is we can write. Any questions?
So actually quickly, are these rules inbuilt into the database itself, or are they separate?
So yeah, so for every database, there's a set of rules.
Right.
So it's like
So you can't create rules within the database.
No, not after the fact. So it's like
So you have to have like
it's static. There's a static
Connect
rule
4
set
database
from the beginning. Yeah,
Okay.
but there's like they have things they're trying to do to be able to migrate data over to like an updated rule set. But that's getting a bit complicated.
Right. So a move is a piece of data you can put in that needs to be externally validated by, I think you used before, it can be accepted as part of the Holochain.
Yeah. So like the idea is like if we actually step through what happens. So when someone uploads some data, they write it to their own local chain. I'll just do. So this is an app with like agents in the app, and then maybe so this is one agent, and then this is what's happening in their computer, right? So their first entry is saying I'm running this DNA. So these are the rules that I'm obeying. So everyone validates that they're actually running the same rule set as everyone else in the network. So that's like you want that to be the first thing that everyone checks is like, should I actually be trusting this interaction I'm having with you? I hope you're actually running the same rules. If they are, then and then they start talking about like who they are and then some of the entries that they're now adding. So we'll talk about if you play Connect 4, like each of these would be a move. So like I make a move and then I make a second move and so on.
Is DNA per app?
Yeah.
Okay.
So the DNA you can actually hash the DNA, and then you get a hash address, so that you get a DNA address. And so if everyone, like basically when you start running a Holochain application, it uses that DNA and then talks to all of the nodes running Holochain like around the world, and it goes, who else is running the same DNA? And if you are, then you start connecting together, and then you can start interacting. So it's like if Nathan and I just started joining, like it would actually we start talking to some bootstrap nodes to help us actually connect. Right. But then once we discover each other and we realize we're running the same DNA, then we can start participating in this.
Right. So but you could have actually a larger Holochain which just has the DNA inbuilt into it, so everyone can check. So you say I want to add this entry using this DNA. People can verify. Anyone can verify it because they've got the DNA also.
Well, they're actually like obliged to do so. So people are like, if we're all running the same app together, if I upload something, there's going to be some nodes that are randomly selected, but it's not random because it's based on the distance between your agent address and the entry address, but like alphabetically. But like those people are obliged to validate and store that data. So this is where you get the redundancy. So there's maybe like 3 people at least. There's a very simple scenario that's supposed to validate and store that data. But you could have like differences between like maybe you only need 100 people storing a redundant copy of that, but then you want more people validating it, so you get like 1,000 people validating. Which should be really good for like financial transactions because you want to make sure they're like really scrupulously audited.
And so with the DNA, do they have to have the exact same DNA to like be able to like access their private stuff, or can there be like a hierarchy of sort of different types of DNA that can be accessed? Like if they can only access the first node or whatever if they've got this rule, if they agree with this rule, but they can't get the rest if they don't have. Does that make sense?
Yeah. So you can always break things down into more applications. So you can always.
So it's more application. Okay.
Yeah, so like if you can access an application, like you're actually both running the same DNA, and well, there's actually like what they call like a genesis, which is like a membrane that's like affecting whether you're allowed in, and then if you're allowed in, then you have access to all of that data inside that. So all of the shared data. You don't necessarily have access to the private source chain data, which each agent stores like off chain, off DHT. But the DHT itself, you can explore that as much as you like.
Just on the DNA.
Yeah, but like if we had some like social network, we all have like one big Twitter, but then like you and I want to have like messaging, like a private message, we would spin up a separate application that allows us to have that peer-to-peer interaction. But you can also just not spin up a DHT and you can just talk peer-to-peer. So it actually supports just I talk to this person if they're online, and then you can send messages back and forth just using like UDP. Okay. So we're running Connect 4. So if we go, cool. So I'm going to create a new game, and then I'm actually going to use, just to make this easier, so this is like, if I already know the other agent's address, like their key, I can just start a new game and connect to them directly. But what you can also do, and I'll do it this way, is you can say, so we say Alice makes a proposal for someone to join a game. So create proposal. Please. Cool. So what's happened is that Alice has created a new game proposal. So like I want someone to join this game. And so anyone else in that network, so anyone else running this as well, would be able to see this. So we'll say Bob goes get proposals. Okay, so this will spit out a list of proposals in the DHT. So there's only one, because Alice is the only one who's put up a proposal. So there we go. So that's the proposal. So what Bob can do is you go accept proposal. Cool. So Bob started the game, and then this is where you just get into UX. But then
I think it's a great user experience.
Alice has to join. Yeah. So join game. So that's on the right. There's just the
How did we know that the game happened?
So Bob's accepted the game, and so then the UI just said, oh, by the way, like the game started. But Alice just like hasn't checked that her proposal has been accepted yet. But I'm just skipping that. But if you're using WebSocket, it does this. Like it would automatically do this and just update immediately.
Yeah.
Cool. So there we go. So they're both playing.
You do have an actual website.
Exactly. This is just like something they should be put together.
You don't have to use command prompt.
Yeah.
You use
So
I didn't mean to pull the movie out of it.
that's right. But dude, CLI is good. Alright. So this is like the kind of move you can do. So the only valid move that's possible is to drop a piece in a column, right? So cool. So actually, I just need to go make a move. So we'll see. I think this should fail.
Where's your food gossip?
Yeah, because it goes. Okay, cool. So Alice made a move and dropped it in the first column. So
But it said non-creator must make the first move.
yeah, because
Is that because Bob joined first?
Bob created the game by accepting the proposal.
Okay, right.
So the proposal is separate from the game. Yeah.
Yeah, okay.
Anyway, let's get into it. Cool. So then now if I just press enter, you'll see that Bob is also seeing the new updated DHT. So he's actually, there's been gossiping going on between the nodes, and now Bob knows the new update. So now Bob makes a move. Actually, well, what I'll do now, just to check, so I'll try and make Alice make another move again. So I want her to try and drop another piece again. Okay.
No,
So she's trying to drop another one. It obviously hasn't appeared. It says, oh, there's your fail. It's not your turn. Must wait for another player to make a move. Cool. So you basically created rules as to like who can go first? So there needs to be a turn order. So now, what makes a move? Which column? Which column?
Was it? Column 5.
So this is like obviously simulating the network interaction, but cool. So there we go, and then if we update, there we go. So now it's just an updated move, and then maybe we can try and do one in column 99. Nope, it's column out of bounds. Yep, so then you can maybe go column 1. So, yeah, and then you can win, so on. Lots of plan. There we go. Yeah. So that's Holochain. So you can do whatever the hell you want. That's basically the gist of it. Okay, but one more thing I'll get into. This is sort of talking more about like generally what we're trying to achieve. So we're trying to create these things called sovereign accountable commons. So sovereign accountable commons is a collectively distributed application. It's just like synonymous with like a DAO, a distributed autonomous organization. So the requirement here is that we want at least one person. If one person's running it, it can't be shut down. And so this is what makes this thing unenclosable. So that's a term that comes out of sort of old agricultural practices back in England and stuff, where you had the monarchy come along and go, no, this is our land now, and then we're going to give it to this landlord, and he now owns it. You know, so if someone is running this application, no one can stop them doing that. So if Nathan and I want to play we bloody well want to play our checkers together, we can, and no one's going to stop us. Right? Cool. So sovereign meaning everyone in the group is an equal peer subject to the same rules, processes, and procedures, because everyone's running with the same instruction set. Accountable. So this is interesting. So there's membranes of membership. So to join, you need to, like, there's maybe some kind of ritual involved, but that ritual could just be like do you have a national residence? And, you know, you could have or maybe it's more simpler, like I don't know. We can think about it.
Bob has to invite you.
Yeah, like someone needs to invite you, or you need to have 3 people who have vetted for you before you're allowed to join, or something. So that can be whatever criteria you want. This will obviously include validation of identity. Because the difference in blockchain is like everyone's anonymous. In blockchain, it's very different. So like it's hard to do this kind of stuff. Everything is signed, so there's always a trail. So you can be caught red-handed for trying to do stuff. And it's a commons. So commons is where everything is held in common. So everyone stores a little bit of everything. The authors store the data that they share, and then they can leave at any time, but that data is still, like, that they've decided to share, is still kept in the commons. Cool. And so, yeah, that's about it. Now, quickly, one thing I'm working on using this is I'm really interested in scholarly communication, like I said. So I'm interested in open access to articles and stuff and new knowledge. Transparent, like, peer review processes and stuff, and like actually opening up what's actually happening in the lab, how are people actually recording all this stuff. So you could actually have like IoT kind of stuff where the microscopes and the measurement tools are all directly linked to a Holochain application, because Holochain is so lightweight that you can run it on like freaking like Raspberry Pis and stuff. You can have hundreds of these on a Raspberry Pi, which you can't do with blockchain, right? And then I'm really interested in transdisciplinary intelligence, so having multiple disciplines come together to make sense of the world. So this is like this is a graph that I really find really interesting. So this is an example of understanding how flows and the currencies are actually helping us map the territory and come to like better decisions about what we can do. So this is a map of citations in all of the disciplines. So you can see how there's certain disciplines that are really highly interconnected. So like cell biology and medicine and physics, they all talk to each other. There's chemistry in the middle. So chemistry actually like acts as a bit of a conductor between physics and biology and stuff. And then you have economics all the way over here, which is like totally disconnected from like the actual science actually kind of interesting when you are able to map what's going on and you can go, oh, this is like not what we expected. So there's like very authentic, like the actual paper, the people who did this is a really interesting paper to read. There's a reference there. Yeah, I'll also share a link with you for all this stuff later. Yeah, and then there's the app I'm building called Omni. So, it's starting off as like a bit of like a Reddit clone, so I want people to be able to sort of share anything, but then eventually people will be able to actually share articles and publish stuff and have it peer reviewed and everything, so you can actually do science fully peer-to-peer, which is really interesting. So you don't even have to be part of a university to do science. Cool, and so I've got a reading list there. I recommend everyone jot that down. It's really useful. Yeah, so Nathan and I also run a Web3 Sydney meetup every second Sunday. Yeah, we just basically talk about this kind of stuff. We really just talk about Holochain because we're obsessed with it. But there's like whatever else we want to talk about, like other blockchains and IPFS and card stack and whatever else people are familiar with. But, yeah. Cool. Thank you.
Thank you.
Can you show us more of Omni?
Omni? No,
Yeah.
man.
No.
I've had to reset lately, so because everything's been updated.
Oh, right.
On the Holochain end, so I'm starting over.